So as I said, my name is Murray Oldfield. I'm a technology architect at InterSystems in the Architecture and Performance Group. We're based in Boston, but you can tell from my accent that we have members of the group all around the world. My goal here today is to make sure that when you leave the room you understand a bit more about hyper-converged architecture if you're not using it already or you're not a vendor, and that it makes sense for you and that you can make decisions about whether you want to use it to run your business critical applications, especially cache and IRIS databases, because they have special demands. So our group does work closely with vendors doing benchmarks, so we get a lot of information, we exchange a lot of information, and doing that we get to understand their products, how they work with IRIS. The information goes both ways. They advise us how things should be set up, and we often feed back to their engineering groups too about improvements that we can see when you run really high performance databases on these type of infrastructures, because they are a little bit different from where hyper-converged started off. I'm assuming you guys in here are somehow responsible for designing and specifying infrastructure, and you need to plan and you need to understand the differences between this and perhaps where you might have come from in the past. So this infographic, you've probably seen it around a few times in various forms. It's all about the storage market. So starting on the left-hand side, we can see that back in the early days, before 2014, pretty much everybody was using storage arrays for their databases. And then along came HCI, the blue area at the bottom, and that started to eat into that market because HCI at its heart is really a storage solution. The other thing that's going on at the same time is people are moving into the cloud. So what I'm seeing when I talk to our customers around the world is that they're going in one of two directions. If they're going to the cloud, that's what's happening. If they're staying on premises, inevitably the question comes up, does IRIS run on HCI? Does it run on Nutanix? Does it run on VMware vSAN and various others? And that's happening more and more often until it's basically a standard question now. And the answer always is it depends. It depends what your application's doing. And that's what we're going to talk about today. So to start with, there's several questions we're going to answer here. We're going to talk about what it is, just make sure we're all on the same page. There's some different terminology that's used with HCI, and I want everybody to understand what that is. And it's really valuable because one of the things I find is that there's a gap between what people understand and when they talk to their vendors and describe what they need for IRIS, for example, and what the vendor thinks they need. That's probably one of the biggest problems I find dealing with customers. So when you're designing, you need to consider your availability, your sizing and performance. And what we're going to talk about mainly today is the availability and sizing and performance. And the focus here is on infrastructure. So there's lots of questions. Sometimes the answer isn't really that obvious. So back in the day, we had traditional architecture. It was all, separate storage, separate servers. Everybody knows how this works, networks and so on. And, everybody started moving to blades. Then around, 2010, things started to become converged, which means that, yes, we still have separate components. It's still a server. It's still a storage array. It's still a network switch. But the vendors were starting to bundle these things together. And the value for that was, when you have something like VCE, which was VMware, Cisco, and EMC at the time, what they did was they would put VMware on top of some infrastructure and ship it out as a whole unit. All the firmware was the same, everything worked, everything behaved as expected. There was a little bit of a lag when there was upgrades and things because everything had to be checked at the factory before they would let even a firmware for a NIC card go out the door. So things were a little bit interesting. And then what happened was we moved on to hyper-converged. So, and that's what we're here to talk about today. So the really big differences here is it's a software-defined approach. So we've still got servers and storage, but they're configured in a different way, and they're built on top of, they're built using software rather than different hardware components so much. So what I'm going to do is go in for a zoom in. I'm going to talk specifically about the two biggest vendors that we see customers using is one called vSAN from VMware, and VMware's out there in the Solution Exchange, but also Nutanix, and then there's a few others around. So who here is, somebody mentioned they're running infrastructure, they're running hyper-converged already. One person, two. Cisco. So that's the interesting thing that I was actually about to point out, is that hyper-converged isn't a technology or even a blueprint or anything. It's a marketing term. So what vendors are doing is, all sorts of things are hyper-converged now, and they don't follow the, where Nutanix, for example, started off, or where vSAN is today. They're basically saying, well, we're packaging our stuff in a certain way, but we're going to call it hyper-converged because there's an element of software definition there. Now, the things I'm going to talk about as far as performance and so on really apply whether you're doing hyper-converged or whether you're just deploying on normal storage anyway. So a lot of the things actually follow. So if you're using a different sort of vendor, there's going to be a little bit of mapping going on. So back in the day, in this picture, we've got 3 hosts with some number of VMs on them, and at the bottom there's a storage array. And what that storage array has in it is it has storage controllers which have memory, and nowadays a storage array storage controller is effectively a server. That's how powerful they are. And that was front-ending all the I/O that was coming from however many hosts you had. Down on the storage, there was, disks were laid out, and whether it was some sort of hybrid thing, where there was some flash and some spinning disk, or whether your disks are in LUNs, or as Pure does now, uses vVols and software-defined mapping down on that layer. It's still a separate element. It's still got some very powerful processing involved, built into it. Then we move into hyper-converged, and one of the most common things about hyper-converged is now we still have our separate hosts with our separate VMs on them, but what's happened now is the storage is moved up into the hosts, and that's a little bit of a concept for a lot of people. We're still having shared storage, so it's still a shared pool of storage. A VM on host 1 can still see its storage no matter where it is on that storage layer underneath. It doesn't have, it's not local to the machine, or not specifically local to the machine. And if we zoom in a little bit further, this is a picture which follows very much the Nutanix and the vSAN architecture, where we have tiered storage. We have a cache tier and a capacity tier. Now, the cache tier is used for when you do writes. So if you write to a disk, it hits the cache tier, and if you've got some hybrid architecture where the capacity tier is spinning disks, that's read-write cache. However, nowadays pretty much everybody deploys all SSDs, and if there's one takeaway you want to take from this session today is if you're planning on this, don't put spinning disks in. The economics are now that you really can go all SSD, and the other thing is that when you're talking about what we want to put on this infrastructure, which is a database, high transaction rate, mission critical stuff, you really need the fastest storage out there. And I'll talk a little bit about what that means for cache as well, and why it's important for cache and IRIS. There's some other things going on in that picture. As I said, the data is distributed across all the hosts. So the fact that I write from VM on host 1, it can end up anywhere, and we'll talk about that in a second. The capacity tier, what we really recommend people do nowadays is make that NVMe disks, because they're very fast, and they're very fast because they have very wide write queues, so you can write a lot of information very fast, which once again is really important for IRIS. And the capacity tier, that can be still SSDs, but it doesn't have to be quite as performant as the cache tier. When you are all SSDs, that cache tier is just for writes and maybe a few reads that may be hot, but generally it's for writes, and that's important for cache 2. Any reads come straight off the capacity tier. Remember, IRIS is an in-memory database. Let's hope you're not doing too many reads. You know, that's important. So it's mostly about storage. Okay, let's just talk about some of the technology terminology, because I'm going to mention it and I don't want everyone to get lost. So the first thing is object space reservation, which is just thick or thin provisioning. Nutanix are all thin provision. Now, that's not a bad thing or a good thing. It's just that it's not available from them. Storage-based policy management. This is software defined. So what that means is it's actually one of the really value propositions from using these type of technologies. Whereas before you used to have to carve out LUNs and a certain number of disks, and you would separate your journal disks from your database disks, you know, in separate LUNs, or all of that stuff. Now you can set policies based on your requirements. So journal disks, you can make them have a certain profile as far as what RAID type they are, what sort of other attributes you give them, perhaps things like should they have compression or not, and so on. So this idea is actually really powerful, because now you can have one VM, but you can really be quite granular about how you define the storage that it runs on, and that's a great feature. The other one is that failures to tolerate is just talking about high availability. It just says if I have 3 hosts, how many hosts can I lose and still keep operating if I have 5? If I can tolerate 1 failure, then I can have 1 less. So that's your n+1 that we're all used to. And Nutanix just calls it replication factor, but it's actually the same thing. Erasure coding, I'm not sure why this word's used. It describes the technology, but for us, it just means it's RAID 5 or RAID 6. And we'll talk about that in a second too. So why is this important? It's important because it really impacts your capacity planning. If you have failures to tolerate as 1, you're going to end up with RAID 1 as the default for vSAN and Nutanix. What that means is if I have a 10 terabyte database, it means that on the disk there's going to be 2 lots of 10 terabytes. It's mirroring, just like our IRIS mirroring. So every time you write, you're going to write twice, and there's going to be just a witness as well, just a small component to arbitrate if there's a split brain, if the system can't figure out who's alive and who's not. So if my VM is running on host 2, my data can be anywhere in here. And for simplicity, I've drawn it this way, so it's just split up into 2 groups. And if I get a network partition or a host failure or a cache disk failure, one of these things is going to stop working. But you can still keep working, so that's fine. Failures to tolerate now is set to 2, so I can actually lose 2 hosts, or lose a host and a network partition. Things have gone really awful. Now I've got 3 times the data. So this is really important, because what we recommend for production systems, and for some reasons I'll get into in a minute, is that for your production databases, for your high transaction databases, you want to have the mirroring. You don't want to have erasure coding turned on. We found that that's the best performance you can get. Depending on your application, you may choose differently, but that's where I'd recommend you start. So with erasure coding, what it does, this is RAID 5. It spreads out the data, but what you get here is, as you can see, you just get a much lower storage overhead, 1.3 times, because the way RAID works, it's not mirroring everything, it's just spreading it out and writing a parity bit. If you have a network failure and this gets isolated, that data can be rebuilt somewhere else after a certain time, and then it's all available again. So that's what we recommend for your non-prod, dev, anything that doesn't need the high I/O requirements. And RAID 6 is just we're adding another server. So the other thing that's going on with this picture is that you're seeing that the number of hosts is going up as we do this as well. So if I go back to, say, the RAID 1, I need 1, 2, 3 hosts at a minimum, plus if I want n+1 for maintenance and all of those type of things, I really need 4 hosts as a minimum for this configuration. So that's another thing that drives decision points around, if I'm going to be isolating and just using HCI for an application, then there's actually a minimum entry point. You can actually do smaller ones, but for big production databases with your business critical applications, then that's the minimum. What we see actually in practice is most people have a much bigger cluster of servers, and the applications are one of others. But that's something important to understand as you go into this, because what I see, I deal a lot with hospitals, I deal a lot with the track care customers around the world. They quite often will put in a cluster that's dedicated just to the EHR system. Nothing else runs on it. And that's fine when you have a 3-node cluster in the traditional sense with some external storage. But if they're going to go to this model, they have to think a little bit differently. Okay, so what do I need to consider? First of all, you need to understand. So if you're contemplating the move from going from something else to HCI, you have to know what your system's doing now, because there's some decisions that you have to make. So these sessions, the next one is upstairs straight after this, and the next one's upstairs straight after that. So that the performance metrics is more understanding how to grok your system, understand what your requirements are if you are planning a move like this. The system alerting and monitoring is again along those same lines. So, and you have to listen to me. So if you don't like half Kiwi, half Australian accents, you're in trouble. I also blog a lot on the community. Who here goes on the developer community? Yeah. So I do it in fits and starts. I really should be more proactive, and I think I will be. I always say that every year. But the thing is that it's very weighted towards HCI, VMware, because that's most of the customers I'm talking about are using that. So I'm trying to put down my experiences, help people in the design process phase, rather than the, oh golly, something awful's happened to my system, how do we fix it phase, which has happened a few times. So I'm going to talk about a little bit about the performance stuff, and it's just a couple of slides. So this is a chart of a system, and the orange line at the top here is actually on this axis here over on the right-hand side. So this is database reads. So this is a system, in fact, running a synthetic benchmark. It's just a customer. They sent me some data, so I thought it'd be interesting to look at here. And so they're doing not too many reads a second. It's a funny sort of application. But they are doing a lot of writes, which is the blue blips going across here. They're doing 16,000 writes per write daemon cycle. So it's a very heavy write workload. So what else is going on here is we've got journal writes. So as you know, whenever transactions happen, we write out to the journal file continuously. The very spiky pattern of the database writes is because we usually write about every 80 seconds, all your random stuff. So all the database changes happen in memory, and then every 80 seconds they get written out to disk. And just before, there's another little blip, something called the WIDG, the Write Image Journal, writes out a big sequential file first that says these are all the changes I'm going to make in case there's something awful happens when I'm actually making the changes to the database. It's a way of belt and braces, and that's our data resiliency model, and it works. If I go to the next slide, the customer was evaluating an HCI system, and they did no tuning. They hadn't talked to anybody at InterSystems. They just threw the application on there to see what would happen and what it would look like. So this is a quarter of the workload of the first chart. Once again, it's a synthetic workload, but there's something different in this diagram, or in this chart, sorry. We can see that the reads, this is latency. So the previous slide was latency. It was just reads and writes, what they were. And here's the latency. So what's happening is, usually we want read latency to be in single digits at least, like less than 9 milliseconds or less. Usually nowadays with flash storage, it's down in the less than 1 millisecond. For writes, we want less than 2 milliseconds. If you can see the read latency, it's going up to about 4 milliseconds, which is not too bad, but remember this application doesn't do much reads. But the write latency is going up to 175 milliseconds, which is a lot more than 2. So what's going on here is when we're doing a big burst of sequential writes out to these disks, the system was not able to handle it. They started to queue up, we get very high latency, and ultimately it's affecting the reads on the system. Now if we had a normal transactional database, we're going to have users complaining because the reads are starting to slow down. Users don't care if the writes go slowly to disk, but users care if reads are slow, because reads are what's coming up on their screen. You know, they're waiting for a page to fill out or something. So these are the sort of things that we work with the vendors to understand and then to tune. So I'm going to talk a little bit about that. So are there any special considerations when you are deploying HCI? And the answer is yes. We have worked with the vendors to come up with some guidelines. They're out on the community. If you go to my community page, I've written a whole post about things you can do in IRIS and things you can do with your HCI to minimize what we just saw on those charts. So to basically configure your system so you're going to get the best outcome. So if it sounds like I'm trying to frighten you, I am. I want people to not just throw an application on there, especially if it's a high transaction rate database like an EHR or something like that. You really have to plan this out. And the problem I find around the world is that what happens is the sales organization of various companies will go out and they will sell a solution for an enterprise, but not consider the little pieces of the enterprise that are working there. And if one of those little pieces just happens to be a high transaction database like IRIS or Cache, then we do get those phone calls. Oh, it's not working. And then we go into panic mode and we're trying to repair things on the fly. You know, if we'd started out in the right way, had a conversation that included InterSystems, people like myself, included the vendor, because even though the local vendor in your area might not know what IRIS is, the top of their engineering chain does. So we can bring in people to help advise, or when people say, I don't want to do that, it's going to cost too much. Well, maybe we have to work out something. So a triangle, us, the vendor, and the customer. I'm just seeing if that clock's counting up or down. So I'm going to skip through just some high-level things to think about. You know, this isn't the time to sort of get too far into the weeds. for a start, HCI is built on x86 architecture. Most of our customers are running VMware. So start off with your VMware best practices. If you do that, you're a big step ahead. And I've got a fair bit on the community about best practices for IRIS and cache. Remember that picture I showed you of the storage array and the storage controller, which is effectively a server? All the stuff that it was doing is now being pushed up into those hosts. It's being spread out amongst multiple hosts, but it's still being done by them. So when I do my capacity planning, I just add another, if I think I need this many CPUs, I just add another 10% for the host level because it's got to do some work. So the other thing in that picture is, and it's sort of not so obvious, but if I'm on a host 1 and I write some data out, chances are it won't end up on host 1. It'll end up somewhere else in that cluster. So all of that I/O is going across the network. So one of the first problems we started to see with customers was bad networks led to bad performance because effectively your write I/O path is now across the network. So you can't cheap out on the network. We have customers use fabric extenders. They've used cheap switches they've got from goodness, the back of the closet. And we've even had issues with things not being on the hardware compatibility list and firmware not being right, which has all upset the network. And as soon as the network's upset, the I/O stops working properly. So there's some general rules of thumb. Apart from the big picture, don't cheap out on the network. You can, 10 gigabit Ethernet used to be the minimum entry from the vendors, but now 25 and 40 and even 100 is becoming sort of normal. RDMA is a technology that goes into NIC cards, which bypasses the stack so that the network traffic doesn't have to pass through the TCP/IP stack, and so that things are faster. So I get excited by stuff like that, but I can see most people looking at their phones. And storage. Okay, so this is where we're talking about, there's some features you can turn off and on. Object checksum is something that goes around. Flash storage is great, it's super fast, but it can get something called bit rot. So what happens is the little cells start to degrade and then your data goes missing. And if you're in healthcare or finance, you don't want your data to go missing. So this is just something that goes around and checks for things that are about to fail or have failed and fixes them up. So it used to be that this was a feature you could turn off and on. Most vendors now, I think, stop that. You have to have it on because people thought it was a performance hit, but you can't do that. Dedupe and compression, if you have databases that have a lot of I/O activity, this adds a certain amount of overhead. Instead of us doing 2 writes, for RAID, we're adding some overhead now for some processing. For your production databases, cache databases are 8K blocks usually of unique data with pointer blocks and things. So they don't, and at the levels that the dedupe and compression works, they don't actually dedupe and compress that well. So for your databases, you can turn it on and try it in dev and just see what happens. But as a rule, start off with thinking about no for your production database. For other things, there's no harm in it. And thick or thin provisioning is more about layer 8. I want to make sure that my database that I think is going to be this big, that data is going to be there. That storage is going to be there no matter what. Somebody's not going to steal it from me. So that's all that's about. It's not a performance thing. It's making sure it's available and not stolen by someone else. Encryption, you can turn it on. Cache database encryption is at the top here. If you encrypt your database, then it's not going to dedupe very well, or compress. So you just make a decision about what you're trying to protect. If you're trying to protect from someone stealing your disks, then you need to encrypt your disks. So the initial recommendation here is for production, use your failures to tolerate 2. Remember, that drives how many hosts you've got. And non-production, you're not so concerned, although it depends how much your developers cost if their system goes away. So should you consider HCI? Well, sometimes the question comes up if it's a very small implementation, it might not be the right fit. If you have very unbalanced workloads, so if you need to provision a lot of storage but you're not doing much processing, then maybe things don't work out. If you have a bare metal workload, I can't really think of any nowadays. I rarely see a customer who has to run on bare metal in the x86 world. Everybody's using VMware, and now people are starting to layer hyper-converged underneath. And the business reasons are just that we're an IBM shop and we run AIX, and well, you can't run HCI really. And as we saw, those very high write I/O workloads, which that particular customer actually does have that, and they do use IRIS and they run on VMware. It's going to be a little bit challenging to see if we can actually make that work. It's a really high transaction rate financial database, so if it doesn't work, money's involved, so people really care. And this is another alternative that people consider as well. Maybe they have an organization that has hyper-converged already. They have a big fleet. Maybe they're running on old hybrid stuff that's not really suitable for databases. You can still have high availability with cache database mirroring. So we do have some customers who just run a small set of servers and in fact use local storage in a mirror. That is a bare metal case. Or they could be VMs, that doesn't really matter. But that's just something I've seen in the field. Okay, so understand your requirements before you start down the path. Make sure you really involve us. People in my group, we're scattered around the world, so we're more than happy to talk to the vendor. We're more than happy to talk to you as a customer and advise you. All flash, as I said, is really table stakes nowadays. There's no real reason to go in with spinning disks. And maybe if you're thinking about it and you haven't started yet, it's something where you start off with your proof of concept, your dev. I'm sure the vendors will help you through with that. And we get to the end. So if you could fill out the survey in the event app, it does help us to decide what we do at our global summits. And usually these talks appear on Learning Services website, and eventually they usually pop up on YouTube. So with that, or if you have questions and you don't want to ask them in the group, certainly just talk to me if you see me around. And that's it. That's the presentation.
I have a question for you.
Sure.
Thank you. That I/O sample you showed us,
Yes.
what was the customer's problem? Was it the disk when they switched to the HCI environment and the read latency went up and the write latency? What was the issue? Was it the disk?
Right. So I'll just for the record, what was the issue with that customer who was having very poor I/O performance? The issue was a couple of things. One was that one of our recommendations is that you turn on something called direct I/O. So we bypass, so that makes writes very fast. It's usually not something that most customers need to do, but for hyper-converged, we found it really helps with vSAN and Nutanix, for example. There's other things around increasing the number of disks that are involved in the I/O itself. So using, if it's on Linux, using logical volume manager to create groups of disks which appear as one disk. So when the write comes down, it's not going down to in a certain queue width depth. We're spreading them out that way, and so that's how we get past that the wedge write, the very big sequential write, which is the one that upsets HCI. So that information is actually on the website. That's the crux of it. So they didn't do that, and there was some other issues. It wasn't vSAN, it was another vendor, in fact. But they hadn't done anything. They hadn't even followed VMware sort of best practice for IRIS. So there was a lot of things they could do to make that better. Also, I believe they'd bought. It was one of those, and this comes up a lot. It's not the group that we were dealing with had made a decision to go to HCI. The organisation had made a decision to go to HCI, and because they had a fleet of desktops and stuff and it's perfect, absolutely the best way to go. But now you start throwing on your databases and other things that really require this high bandwidth and really truly require good performance, and it's not tuned. The people who are running the system sort of weren't aware. So it's a problem we can probably fix, we hope. Otherwise, they stay on the existing infrastructure or do something else. But that was a special case. No problem. Yep.
Curious with HCI solutions, are you finding that as people grow larger and larger on those, the way that they're scaling up their software is through ECP? Or
right.
Because sort of what you outlined there is as my I/O increases on one of these systems, my CPU overhead of the software-defined storage layer is also going to increase proportionally with my workload. So I'm kind of starving CPU from both the application use growing and my I/O requirements increasing. With that move to ECP, have you guys done any testing with an ECP workload on vSAN?
Yes, yeah, we have done ECP workload. So ECP is actually, it's an interest. So the question is, does ECP help or hinder? It probably doesn't make any difference, to be sort of a short answer, because with ECP, what you're doing is you've got your database server, and then you've got some number of application servers which are doing the processing. And so what happens is, have we run over? So what happens is all the I/O is still going through the one database server. The ECP application servers don't do any I/O down to the disk. So you can spread out your application issue if your application is grown bigger than a host, but you're not going to change your I/O picture because it's still all going through the DB server. I think the timer was set from when I started talking, not from when the session started and we had the issues with the laptop. So, is that right?
I started on time.
Oh, you started on time. Okay, so we've got a minute. The other thing I didn't mention, but you just reminded me, is if you're going to, you don't need to do database mirroring if you've got all this FTT equals 1 or 2. And if you think about it, database mirroring doesn't achieve a lot because you're going to get 2 copies of your data, so all mixed in on that storage pool, and you don't know where it is. VMware is going to put it where it thinks best, or Nutanix or whatever, and you're going to end up with not 2x or 3x your storage requirement. You're going to end up with 6x, and so there's no gain. So if you're going with HCI, use the HCI for your mirroring type availability. If you have that other little picture with the 2 mirrors, that's a different picture again. Maybe we could talk a bit more about why you need to go to ECP, or is it more a general question? Okay, cool. All right, that's it. Thanks for coming.